All right, so we're just going to quickly go through this last example of 9b here, and this is a little section on strictly increasing and strictly decreasing intervals. This kind of idea seems relatively straightforward, but can be a little bit tricky, particularly with one part of this. So when we think about the word increasing, we know that just means like going up, and when we think about decreasing, that just means going down. And that is still how you need to think of it for this section, but with, I guess, a slight exception to that. And the reason is that when we think about these strictly increasing or strictly decreasing intervals, we are actually thinking about a range of numbers rather than specific exact points on the graph. And so what we say is if we have some interval where a is a smaller number than b and the interval is from a to b, then a function is said to be strictly increasing if b being greater than a implies that f of b is greater than f of a. So what that means is that if, as we move to the right, if the number on the right is always bigger than the number on the left, then that means the graph is going up and it is strictly increasing. The second one says that if b is greater than a implies that f of b is less than f of a, then we've got an interval that's strictly increasing. And really all that means is that the value to the right is less than the value to the left. And if that was happening, value to the right here, value to the left here, well, the graph must be going down, right? Whereas in that first case, it was like the value on the right was bigger, so the graph must be going up and be increasing, okay? Stationary points, really, really useful for us. So remember, that's turning points or stationary points of inflection, where they're greater than equals 0. These are really useful to determine where functions are strictly increasing or strictly decreasing. Let's have a look at an example, and hopefully, as happens in many cases, the example will help make things a bit clearer. This one says to use your calculator to sketch the graph of y equals 2x cubed minus 6x, and hence state intervals over which the graph is strictly increasing and strictly decreasing. Okay, so in my calculator here, I've just typed the equation into the main screen, and I'm going to pop this onto a graph. And we can see, well, before we even graphed it, we could see we had a positive cubic. Now we've got a better picture of what's going on, and these turning points are going to be our key points here. Now I'm just going to try to get in a little bit closer. Yep, beautiful, can still see the two turning points there. So let's work out where that maximum is first by just doing analysis G-solve and then max. And that maximum occurs at -1, +4. So I'm just going to, even though the question didn't specifically tell me to sketch it, I'm going to sketch it down here. Now, probably not a great picture, but it should be good enough for doing what we want to do. So it was -1, +4 for that maximum. And probably got a good idea from the scale, but let's just make sure we know where that minimum is. Analysis G-solve and then minimum. Yeah, that occurs at 1, -4. All right, now we're really talking about intervals in terms of x. So the y coordinates aren't super important there, but what is important to know is that the maximum was at x equals -1. The minimum was x equals +1. Okay, so let's think about where is the graph, well, strictly increasing, but let's just think generally first about where is it going up? Where is the graph going up as we move from left to right? And looks like it's going up and up and up, sort of from everything to the left-hand side all the way until we get to this turning point. So we've got a section here where it's going up, all right? We've also got a section at the other end from 1 onwards where it's going up again, okay? So when we talk about where it's strictly increasing, we're going to be talking about those two sections, right? It's strictly increasing from -infinity all the way to -1, and then from +1 all the way to +infinity. So we can write that as a union. So we can say that x is an element of -infinity to 1. Now, this bit might seem a little bit confusing, but you actually include 1 in the interval. Even though at the point sorry, not 1, -1. We include that -1 in the interval, even though at the point -1, we've got a stationary point. When we're thinking about it as an interval, I could say that from everywhere from -infinity all the way up to -1, including -1, if I pick any two numbers in that interval, then the number on the right will always be bigger than the number on the left. And that's why we include the -1, because it's part of an interval where the numbers are always increasing, even though at that exact point, the numbers aren't increasing anymore. It's a confusing point, but I hope that makes a little bit of sense. So we're going to say union, because remember that our other interval where it's increasing is from 1 to infinity. And again, because we're thinking about an interval, we're going to include that 1. Again, it's not increasing at 1, but anywhere in the interval from 1 to infinity, the number on the right, or the value on the right hand side, is always bigger than the value on the left hand side, and that includes if you start from 1. Okay, which is why as an interval we're including the number 1. Okay, so that's our answer for strictly increasing. Strictly decreasing, well, the bit where it's going down is in the middle, from -1 to +1. And again, with these stationary points, even though at the stationary points it's not decreasing, they're still part of an interval where we could say that the number on the right is always lower than the number on the left, or the y value on the right is always lower than the y value on the left. So we're actually going to include the -1 and the 1 in our strictly decreasing interval. Okay, so try your best to understand why we're including those endpoints, but I guess as a rule, you can think if the question's about strictly increasing or strictly decreasing intervals, typically what we're doing is we're including the stationary points in those intervals. Seems a bit confusing, but do your best to get your head around it. And as always, contact your teachers if you want a bit of extra explanation about that one.